All right, so today we're going to talk about factor by grouping. The hint, the clue that we will possibly, that factor by grouping might work is when we have a 4-term polynomial. Because so far we've been factoring a 3-term polynomial, 2x squared plus 3x plus 5, or a 2-term polynomial, like x squared minus 36. We did those yesterday. So those are the 2 types of polynomials we've been factoring so far. Today we're going to talk about 4-term polynomials. So I just want to go through a few examples, because we really already have the tools that we need to do this. So we want to factor what do I have here? X to the third minus 4x squared plus 5x minus 20. So this doesn't look like anything that we factored so far. We have a third power. We haven't really factored anything with a third power. There are no GCFs here. There's nothing that goes into each term evenly. So this is when we think, okay, we might be able to use factor by grouping. I'm going to show you 2 ways. The first way is how factor by grouping got its name. And the second way, we're just going to use the box that we've been using for other polynomials. So factor by grouping, what we want to do is I'm thinking of grouping the first 2 terms, the highest 2 powers, and the next 2 terms. So this is where the grouping comes in. I've grouped these together. And now we want to factor out the greatest common factor out of each set of parentheses. So the biggest number that goes into both 1 and 4 is just 1. The smallest power of x that goes into both of these, well, both of these have an x squared. So I factor that out. When I take x squared out of x to the third, I'm left with x, and when I take x squared out of this, I'm left with 4. And now I go to the second group and say, okay, what's the biggest number that goes into both 5 and 20? That is 5. So I'm going to pull that out. So that's our greatest common factor here. When I do that, when I take the 5 out of the 5x, I'm left with x. And when I take 5 out of 20, I have 4. For factor by grouping to work, these 2 things need to be the same. Well, now, each of these terms has an x minus 4 in it. So I'm going to factor that out of each of these. And I'm going to write that as x minus 4 times, and when I take the x minus 4 out of here, I'm left with x squared. And when I take the x minus 4 out of here, I'm left with 5. And I can always check my work. If I distribute this x minus 4 here, I get x minus 4 times x squared. And when I distribute the x minus 4 here, I get 5 times x minus 4. Yes? So what we said was each of these has an x minus 4, each, this bit and this bit, both have an x minus 4 multiplying. That's our greatest common factor for this whole thing. Each one has an x minus 4. So I'm pulling that, bringing that out front. I'm factoring that out. Well, when I take the x minus 4 out of here, I have x squared. And when I take the x minus 4 out of here, I have 5 left. Now, this process, this way of doing factor by grouping, can be a little bit confusing. I still have advanced pre-calc students that make mistakes with factor by grouping this way. So let's show how we do this using the box. So we're going to draw our box. And I'm just going to put my 4 terms in the box. X to the third minus 4x squared. I'm just putting each of these in a box here. 5x and negative 20. And then I'm going to pull out, just like we've been doing, pull out the greatest common factor for each row and each column. So what's the biggest number that goes into 5 and 20? 5. The smallest power of x in both of these? X squared. Biggest number that goes into both 5 and 1 is just 1. The smallest x that's in both of these is 1x. The biggest number that goes into 4 and 20? 4. This is negative, so I'm going to put a negative there. And this tells me my parentheses are x squared plus 5 times x minus 4. Just like when we've used the box in the past. So what we're doing in this box is the same process that we did here, finding our greatest common factors. This just keeps it a little more organized. It helps us to see what we're doing. All right, questions there? All right, let's look at another example. Four x to the third minus 6x squared plus 16x minus 24. So our first step should always be check for a greatest common factor. Is there a number that goes into all of 4, 6, 16, and 24? 2 goes into all of 4, 6, 16, and 24. So I'm going to factor that out first. So our GCF is 2. So I'm going to write that as 2 times 2x to the third minus 3x squared plus 8x minus 12. And I'll do both methods, the grouping method and the box method. So this is going to be 2 times, and I'm going to group these two. And I'm going to group these two. The greatest common factor here is x squared. Both of these have an x squared. And what's left when I pull an x squared out of here is 2x. And what's left when I pull an x squared out of there is minus 3. And here, the greatest common factor, the biggest number that goes into both 8 and 12 is 4. And what's left when I pull a 4 out of here is 2x. And what's left when I pull a 4 out of here is 3. Now my greatest common factor is 2x minus 3. So I'm going to pull that out of each of these. 2x minus 3 times, when I pull that out of here, I'm left with an x squared. And when I pull that out of here, I'm left with a plus 4. And that would be my answer. Yes?
Why would you get x squared instead of x without including x on there?
Oh, this should be a x. Why did I write x plus 4? Oh, yeah, no, x squared.
Right, but when, like, I meant 2x minus 3. Like, is 2x more, like, on the last one.
So each of these has a 2x minus 3 factor in it.
Oh, okay.
So that's what goes out in front. All right, let's look at the box method here. So I know at the end I need to multiply by greatest common factor. I'm going to set up the box just for what's inside here. So I get a 2x to the third minus 3x squared and 8x and a minus 12. And for the box, we're just pulling out our greatest common factor in the rows and the columns. Biggest number that goes into 8 and 12? 4. Biggest number that goes into 2 and 3? 1. The smallest x is x squared. Biggest number that goes into 2 and 8? 2. Smallest x here? X. Biggest number that goes into 3 and 12? 3. And it's negative here, so I'm going to put a negative there. And they don't share any x's here. So this tells me my parentheses are, now I need my greatest common factor, 2 times x squared plus 4 times 2x minus 3. Just leave it written just like that. Yes? No, no. On the test, it will say use factor by grouping, use the box. On the other ones, it'll say use the cross and box, use slip and slide. You can use whatever technique that you prefer. This, I think, is a little easier to see. This, it gets confusing from this step to this step. This is where students usually make mistakes. This helps you keep that all organized, and just what goes in the parentheses are just what's here and what's here. So that makes it kind of nice.
Does it matter what order you put this in?
It does not. It does not. And it also doesn't matter what order you put your stuff in this box. You can stack them this way, or you can do them this way, because you just pull out the GCFs. Yes? Uh-huh. Uh-huh. All right, let's do one more example, and then we'll be done. All right, 3x to the fourth minus 12x to the third plus 15x squared minus 60x. All right. Is there a number that goes into all of 3, 12, 15, and 60? 3. Is there, this one we need to be careful, is there a lowest power of x that all of these have? Each of them has an x, right? Because this has an x, this has x times x, x times x times x. So the lowest power of x is x. So we have a greatest common factor of 3x for this one. Yes?
Do you have to find the greatest common factor? Can you make a box with the original numbers?
You could make a box with the original numbers, but then you'd still have to pull out the greatest common factor at the end. So you'd still, they would all still have a 3x, and you'd have to pull it out at the end. All right, so I'm going to write this as 3x times, and I'm going to take 3x out of each of these. So here I'm left with an x to the third, because I take the 3 out and one of the x's. minus 4x squared, because I take out the 3, divide by 3 in one of the x's, plus 5x, take out the 3 in one of the x's, minus, and 60 divided by 3 is 20. Should we go straight to the box on this one? Let's just go straight to the box. If you like the other way, you can still do the other way. X to the third minus 4x squared, 5x minus 20. All right, so let's pull out our greatest common factors. Biggest number that goes into both 5 and 20? 5. These don't share an x. Our factors are just 1 and 4, so the biggest number is 1. Smallest x that's in both of these? X squared. 1 and 5, so we just have a 1. Smallest x here? X. Biggest number that goes into 4 and 20? 4. And this is negative, so we make that negative. And these don't share any x's. So our answer is our greatest common factor, 3x times x squared plus 5 times x minus 4. And that's our final answer. All right, the box works really nicely for factor by grouping. All right, any questions on factor by grouping? Okay, and again, the key, the hint, the clue that we're using factor by grouping is that we have a 4-term polynomial that we need to factor. When we have more than 3 terms, that tells us you're probably going to need to use factor by grouping. Okay. There we go. Our homework. We're in section 8.8, and we're on page 531, and we're doing 14 through 30 even. So we had a lot of time to work on homework in our last class period. So I will answer a maximum of 3 homework questions. Okay? Once I'm done answering homework questions.